Hello, everybody. How we doing? All right, well, we are back here in Kerbal Space Program. I hope everyone's evening is going well. I just kind of got off work, so figured it was time to do some Kerbal Space Program. So when we last left off, we had failed spectacularly at conducting observational surveys of the moon, and bringing back Moonstone was with us. So we need to do both of those missions. We have a sufficient quantity of money. So I guess the trick now is to do piloting. Hey, Dion, welcome. Nice of you to join us. It must be pretty late over there. Is your sleep schedule moving with the change in the world's clocks as we all work from home? Um, yeah. So speaking of which, I'm working from home now, so I'm basically 4 feet away from where I do my day job, which is great fun. Um, just one desk over. All right, so the last time we did this, we had just rescued Jeb. Um, so we got to try again here. So this is going to be our spacecraft, and we need to conduct 3 surveys, land, and then return with a moon rock. Vinfaz, usually we get like 40 people. 40 people's a pretty busy stream for me. 10 is highly chill. Um, but yeah, so the usual format of these things is I fly rockets badly, and then I try and salvage the bad flying of rockets while talking about real rockets. And I kind of have a treat for today. Sometime, maybe when, I'll show what I've been working on for my own personal rocket engines. My rocket progress has been a little bit slowed these past couple of days because I've been working on an emergency ventilator to support the pandemic relief efforts. They're particularly tricky to get right, but I'm working with an incredible team of people and some real medical personnel to hopefully help emoliate that situation. So we've got a rocket here. This is our orbiter, and so our plan with this is to do a low flight over the Mun and capture data from those three sites. But I kind of want to try and also land with this. So what we're going to do is add landing legs. 2, 3, 4. And we're going to add some propellant because I don't think this is nearly enough fuel. So we'll add, that is the wrong size fuel tank. That is the right size fuel tank. There we go. Okay, so now we've got that fuel tank snuck in there. We need to check the thrust to weight ratio. 1.5, so we're not too shabby, so we can really add quite a bit more propellant. Like that. What are we to now? KDR of 1.4. Not bad. Okay, so we just added, several hundred meters a second of delta V. So our goal, this is going to be Mun Explorer 4. So our goal here is, if we go look at the Mun, you can see where we have to go explore. So very helpfully, these spots are marked Oh wow, there are lots of spots marked. But we don't care about any of these. We care about these right here. And for some reason last time it would only let me sample one of them at a time. So we're going to bring along a experiment canister. So hopefully it'll let us sample all of them. And to bring along a sample canister, we need to find a spot to put it. So let's see, would it be in science? I think it is in science. There it is. Experiment storage unit. So we're going to hide it. This is like bad practice, but we're going to clip it into the capsule. We'll pretend like the engineers have moved some of the capsule's consumables down into the service module, giving us an excuse to fit it inside the... There we go. See? Excellent. And now all we have to do is fly this mission. What could possibly go wrong? I always say that. That's the first thing to say. So, we're going to get this thing into space first and then find something interesting to talk about. But this is just a standard launch. So the thrust-to-weight ratio of 1.4 means that we don't have to save our gravity turn for too late. But we don't really have a lot of control authority on this first stage, as we found out last time, so we'll wait just a minute. Sunrise is about to happen right there. See how Jeb's doing. Nice little view. Get to see the sunrise from inside the capsule. Oh boy, okay, tipping over. Oh wow, isn't that pretty? Holy cow. Sometimes this game just looks really good. It's happening more and more since they've started doing graphics updates. When you first played this game in like 2011, it was just, like the planet was just one solid color. And the oceans were apparently like made out of lead. Like you could float on them no matter what. All right, so that's first stage burnout. And we will just keep heading up to orbit. We've got 2,000 meters a second of delta V in this stage, so we'll make orbit and TLI with this stage, no problem. So this bottom of this stage right here actually reminds me a lot of the Atlas first stage. That used to fly like the Atlas D. Speaking of which, there was an Atlas V launch today carrying the AEHF-6 satellite for the Space Force. So it's on the books. The Space Force has its first launch, and I think the other interesting fact here, and I'm gonna run the risk of quoting numbers from memory. I think this was the 83rd launch of the Atlas V, and SpaceX, with their last Starlink flight, also had 83 flights. So Atlas V and Falcon 9 have now flown the same number of launches, which is kind of crazy that in such a short period of time they've caught up so far. So our apoapsis is just at 100 kilometers, so we will fly out there before circularizing. And then we'll do our transfer to lunar orbit. I don't think I really flew quite the most efficient ascent trajectory here. All right. Wow, why is everyone here from New Zealand? Like, isn't it like it's either really early in the morning in New Zealand or just early in the morning in New Zealand? And I'm not sure which of those is better. So last time I flew this mission, I used the Russian capsule, the circular capsule, and that capsule, I didn't know this at the time, it didn't have reaction wheels, so it had no control authority other than when my engine was running. Alright, so... Oh, wow, how convenient. This stage will niftily re-enter and not leave any space debris. So we'll just bring this periapsis up to something. There we go. 120 kilometer by 95 kilometer orbit. Alright, so with that taken care of, we need to start planning our transfer to the Mun, which will happen about here. So we want this to have a really low lunar periapsis, so that we can circularize and then very cheaply do our inclination maneuver to line ourselves up with those two sites we need to sample. So we'll just real quick point around to the maneuver node. Yeah, Hernandez, it's really pretty chill tonight. I guess everyone has better things to be doing in social isolation on a Thursday. Although partly it may be my fault. Let me go ping the Twitters. Tell everyone that we are here streaming Kerbal Space Program. Okay. Yay, tweeting successfully accomplished. Yeah, so we'll fly around and we'll do our trans-lunar injection burn. And then on the way out, we can talk rockets. So I've been working on a couple of rocket projects and a couple of not rocket projects recently. So everyone here mostly knows about my liquid engine that I'm working on. I've gotten all kinds of cool stuff in. I don't think I've showed this off yet, but this is the main valve actuator for my fuel side. So it's a 1-inch ball valve. And then I'm working on another rocket project, which is like kind of top secret, with another rocketeer who you guys might know. I don't know when we're going to talk about that one, but I've got some really cool hardware for that. I might show some spoiler images from that later in the stream. I don't know. Convince me to show pictures I shouldn't show from that rocket project, and I just might. And then I've been working on a 3D printable ventilator that runs off of a 30-watt DC motor to help in hospitals that have run out of ventilators. So that's an exciting project. I'm doing a lot of the controls work on that. Dion, what's the difference between a podcast and a live stream? Because I'm not quite sure there is one. So let's see. This is going to be a 1 minute and 20-second burn. So we want to start at about the 1 minute mark. So we've just got this little LV 909 engine here on this stage. Well, you know, we'll go ahead and extend the antenna, make it look all spacecrafty, and the magnetometer boom. You guys were too drunk on my cooking stream. Were we too drunk? Because I thought it was a lot of fun. Dion, you guys are using nitrous though, right? So you guys don't have to cryo service the valves, right? All right, and ignition. So we have a 1 minute burn here. That looks like it's doing what it's supposed to do. This is sometimes really just... Look at how pretty that is. Holy cow. Alright, so... Once we start flying out to the... Oh, well, you know, Dion, Nitrous, frankly, scares me a little bit. So for those of you guys who don't know, nitrous is another oxidizer you can use instead of liquid oxygen. And it's good because it's self-pressurizing, so you don't need to have a whole pressurization system. But it is bad because it is detonatable, and also your rocket performance, like, actually depends on ambient temperature. So, like, if it's warm out, your rocket may underperform because the density of the oxidizer in your tank is lower. I remember one year at a rocket competition, a team had to shoot their rocket because they couldn't get enough oxidizer into it to launch it, and they couldn't get enough oxidizer out of it to safely approach the rocket, and they were literally just totally hosed. So Dion does a better job than that. The Stratos rockets are absolutely brilliant, but nitrous is still just not something I'd rather not deal with. Yeah, nitrous. I'm with you, Cosmic. Nitrous is just not. I don't. It gives me the EBGBs. I was talking to someone today who wanted to submerge COPVs in nitrous, and that's bad on a couple of levels. First off, carbon in nitrous can form sensitive explosives, but second off, the amines in the epoxy curative can also can also form explosives in nitrous. Vinfaz, isn't Gox more dangerous than nitrous? You know, it's a matter of opinions. Gox can't detonate, but it is you do have to be much more sensitive with your oxidizer servicing. Dion, I'm surprised that it's hard to get locks in the EU. I don't know why that would be the case. Francis, the idea you have is either called a mixed monopropellant or a bomb. I don't know which it is. Depends on how good your chemistry is. But it's definitely there are people who have had similar thoughts, and you have to be very, very careful. Very, very, very careful. But it's absolutely not unheard of to do mixed monopropellants. So we're gonna pull our periaps in closer to the moon. The mun, sorry. 900, 800, 700. That's about as close as we're going to get. So we've got 2,000 meters a second of delta V. That's not really a super whole lot. So that's increasing that. So what we want to do is we want to do a maneuver that looks like that. Nope, that looks like that. There we go. Oh, another 100 meters a second. That's not great. Well, it's cheaper to do it out here than it will be to do it once we get close to the mun, so I guess we have no choice but to do this little 100 meter a second burn. You know what this means? This means that I did my burn for the mun too soon. I should have waited longer. And of course I'm out of electric charge, so I have to wait till we get some power. Alright, let's see, catching up on chat. What is the difference between a rocket and a bomb? Hernandez, that's actually a relevant question, and there's a significant one. Rockets use deflagration typically for their combustion mechanic, whereas bombs typically use detonation, where the distinction is whether or not the combustion is occurring faster than the speed of sound in the material. Oh yeah, Dion, that makes sense, it being expensive. We're lucky that there's like dewars laying around every junkyard here in the United States. I don't know why, but it's convenient. Um, Wow, Dion, that's just bad luck. It's this. There's a lot of teams that are suffering from this. Dion, you know about the sounding rocket competition I'm running, right? To kind of make up for the fact that teams got hosed by the loss of IREC. I'm hosting an online sounding rocket design conference. We'll have industry experts give talks. We'll do design reviews for all the teams that submit design reviews, and we'll hand out awards for all kinds of categories, and there will be prize money associated with those awards. So it's really worth your while to just submit whatever your most recent piece of documentation is. Um, all right, so let's get this burn done. Just real quick. And shut down. So we check in, that's 14,000 meters. Awesome. This is perfect. This is exactly what we want. And we're coming in even at a little bit of a polar angle. So this is actually, this could have been a lot worse. So we'll just quick save before I make a mistake. I don't know why I quick save. I never actually like use quick saves. Whenever I quick save, I end up like launching a rescue mission. All right, so see we're coming over the poles here. So what we're gonna do is we're gonna get into an orbit that captures over these, that flies over these two places to get there. Yeah, Dion, no problem. I hope to see TU submit your system. I think you guys would have a strong entry for the judges to review. Um, All right, so we're going to be eclipsed by the Mun here in just a second, which means that power is going to be a concern because this spacecraft does not have large batteries at all. Should just be a 400 meter a second braking burn. There we go. So now we need to either wait for the moon to rotate under us, or we need to do a propulsive adjustment. And I think the trick may just be to wait. So let's see, I think the Mun rotates this way. Nope, it rotates this way. Okay, so we're really not that, we don't have to wait all that long. So we have to be below 11,000 meters, which means we are definitely too high. So we will do a periapsis lowering at this apogee to get that down to like 10 kilometers. The hard part here is we have to play by their rules. So we have to be below 11.8 kilometers when we sample this. Vinfaz, I have never done realism overhaul in Kerbal Space Program just because it starts to feel like my day job if I do that. The tyranny of the rocket equation gets a little overbearing. All right, I think this is going to be... Let's see. I think we want to lower our apoapsis on this pass. How high are we when we pass over this? We're at 30,000 meters, so we are way too high. So we absolutely have to lower our periapsis on this pass. So let's see, what do we bring it down to? Bring it down to like oh, I don't know, 20 kilometers? The problem is just that if we're too high, we'll be totally hosed. 15 kilometers and 9.2. Let's just make sure we're not about to crash into the mun on the dark side. Nope, I can see daylight through the orbit, so we're good there. Hi, Yukon. Welcome to the stream. Nice to see you again. We are once again trying to fly over these sampling locations. So we've just gotten our orbit down. We should just be one more pass to hit this one, and then we'll figure out what we have to do to hit this one. But we've got a modified version of the spacecraft we used last time with a little more delta V. Hernandez, it's a lifelong journey. The acquisition of rocketry knowledge is no short path. But the best place to start, almost certainly, is if you pick up a copy of Rocket Propulsion Elements by Sutton. It's an incredible book, and there's free copies available as PDFs on the internet. And it's a great place to start understanding all about rocketry, all kinds of things. How about that? We're up to 15 viewers. I guess everyone's sleepy today, but we do have some fun stuff. My printer just finished another part for my ventilator, my mechanical ventilator, and I think I will show off all of my progress on my other rocket engine. Not sure when, sometime. All right. So the question is, we're going to be close enough to count if we overfly this. If I take a crew report, does it count? No, it doesn't. Okay. So we have to wait at least one more orbit. Redstone, there's dozens and dozens of copies all around the internet, and the trick is you download them when you find them. But yes, I am currently stuck in my apartment, Yukon. But it's not such a bad deal. I get to work on rockets, get to play Kerbal Space Program. I wouldn't say that lockdown is very much fun. I miss seeing other humans. All right, we need to wait till we're back above 10,000 meters before we can fly faster. 300, 200, 100. Time warp. There we go. The ventilator will not be methox powered. The ventilator is powered by this right here, actually. This is a 12-volt lead-acid rechargeable battery. So the ventilator will plug into the wall, and then in case the power goes out, the ventilator will keep the battery will keep the ventilator running until power comes back on. All right, so we're going to adjust our orbit just a little bit by burning, I think, north here. And that will pull our orbit up a little bit, so we'll actually overfly it this time. So we'll just point here. Kind of come over here just to see what this does. And our periapsis has now gotten a little too low, so we're going to raise that. Just so we don't accidentally crash. There we go. And our apopsis is 15. So the question is, will we be below 12 kilometers there? This is going to be a game of chicken. Oh, okay, we're good. I thought we were going to crash into that when I looked at it like this, but we're totally fine. 13. Oh man, I think we got a break. I don't think we're going to get low enough fast enough. Okay. So now we will definitely crash into the terrain unless we do something about it. So we have to get this sample and then immediately like burn for the roof. 12,500. Oh, this is going to be close. I do not like this one bit. Whew! It's a good thing we burned when we did. Otherwise, we would not have been in a position to sample that. Okay. So hopefully, in a second, it tells me that we are entering Kerbal plane and we can take the sample. All right. So yes, I sympathize with everyone's supply chain problems. eBay is proving more reliable than Amazon at the moment. Adafruit is only selling to medical device providers, unfortunately. Um, it's a challenge to keep. Okay, here we go. So we're entering the Kerbal plane. So we need to take a crew report, keep experiment, which we will do. And now we need to burn for the roof so we don't crash into the terrain, which would be bad. That's bringing that down and that up. Let's see. Okay, so now we aren't going to crash anymore. All right, catching up on the chat again. Yeah, rocket propulsion systems have kind of been perfected to an art to some extent. If you need it cheap and fast, go with RP1 and liquid oxygen. If you need it high performance, hydrogen and oxygen kind of win. Methane is kind of proving to be a good middle ground for a lot of rocket companies. But definitely some rocket ideas are better than others. Vinfez. Telemetry is typically only stuff that is radioed to the ground. Typically, if you're logging it locally, diagnostic data, flight data, that kind of thing, I wouldn't call that telemetry. Francis, I have some sympathy for trying to program TVC systems, but Joe's the real person you want to complain to about that, because the only TVC rockets I've ever flown had Joe's code running on them. Okay, so we need to figure out how to fly over this one next. But before we do that, we need to take all of our samples, and we need to store them in the sample storage place so we can log them again. Is this worth? No, we'll reset that. All right, so we've already gotten all these measurements. We have 1,600 meters a second. Really, I think it's very possible that we're able to land on this flight. I think we want to try and land right there. I think that's where we can find a moon rock. All right, 62 kilometers. So that'll give us a little more time so these sweep a little more time around. The redstone hive, it depends on what you're trying to do. Gas works just fine for a rocket engine. It's easy to get. It does have a coking problem because gas isn't like a single molecule, but it's a family of molecules. So it would make a poor choice for like a rocket you wanted to do anything. But if you just wanted to make pretty fire, gas is a completely suitable choice. The problem with carbon-based fuels, especially like gas and kerosene, is that they glow yellow, so you can't see your pretty mock diamonds. And if you're like me, there's basically no point in building a rocket engine if you don't get to see mock diamonds. Dion, the other thing about gas is it's actually very seasonal. The gas companies adjust what goes into gasoline throughout the year to improve car performance. And also, gas actually goes bad relatively quickly. It'll gel up and get gunky. Ian, yes, I have heard of the Dragonfly mission to Titan. I just heard that recently. Why was I thinking about that? Um, why was I thinking about that? Why was I thinking about the Firefly mission? I do not know. I'm sure it was some good purpose. Hmm. Nope, I really don't remember. But yes, I have heard of the Dragonfly mission. We're just kind of waiting here for the moon to spin. How about methanol as a propellant? Methanol is a fairly common rocket propellant. I don't know why you would use methanol instead of isopropanol. Methanol is considerably more toxic to people, so you have to be much more careful working with it. And there's not like a real performance benefit. What did Joe choose methanol? Is Joe doing something with methanol? All right, I'm getting tired of waiting for us to fly around the moon. I'm kind of thinking we might do a propulsive maneuver. So we will set up a maneuver. Does not need a lot, just a few meters a second. Um, 60 meters a second. All right, that's worthwhile. We'll do that. And that'll get us the overflight on this pass, and we'll be good to go. Oh man, I love Real Engineering. Real Engineering is like the greatest. I love watching that channel. Okay, so what we need to do here is point at the maneuver node marker. And burn. All right, I think that'll do it. Let's see if we like how that looks. 8 kilometer periaps, I think that's low enough. We just have to be below 11 kilometers. And I don't think we're going to crash, so I think that looks like an absolutely peachy place to try and pull this off. Redstone, I don't think Joe has an engine, a liquid engine, unless I'm sorely mistaken, or he's pulling a surprise on me. Do I need to call Joe and ask if he has a rocket engine? All right, so we need to take a crew report. And I think that did it. Ah, yes. All right, so now we're going to land. We've got 1,500 meters a second. We'll use up 500 to land, and then we've got 1,000 to get home, which is just possible. So here we go. What could possibly go wrong cutting it this close? We're going to be landing just as it gets dark, which also may not be like my finest move ever. So what we're trying to do is we're trying to land in the highlands. I'm starting to get suspicious that this engine is not as efficient as it claims, or maybe the delta V calculator is not entirely correct, because this is the second time that that number has dropped faster than it should have. Hernandez, I have heard that they're considering about not using the gateway as part of Artemis, and I think it's probably a good decision if our goal is actually to land on the moon. Alright, so we're timing our suicide burn here. We're playing chicken with the ground. We are 20 seconds from impact. We are now 15 seconds from impact. We're going to start slowing down. Okay, that was way too soon. Alright, that makes us 14 seconds away from impact. I do not like landing when it is this dark. Okay. We're 200 meters off the ground. 150. Oh man, I cannot see a darned thing. $50 down by 6. 40 down by 4. 30 down by 3. 20 down by 6. Touchdown. Nope, no, let's not fall over, please. Why are we still maybe falling over? Oh, come on. We can't do this. Okay, the spacecraft is now very fallen over. But we've landed! How about that? We'll turn the lights on now. I can't see a darned thing. So launching is going to be an interesting exercise. And in fact, on that note, we're going to save all the power we can. So we're going to turn that light right back off. We'll take all the science we can. Take a crew report. Log some pressure data. Log some temperature data. Let's see, where's the thermometer? There's the thermometer. Yes, yes, Dion. As always, it's a classic KSP landing. Hopefully Jeb does not need rescued from this one. I think we can make this work. I think we can hack our way around it. But what we really need to do now, and thankfully I think we landed on the right side up so that we can pull this off, is we need to go find a moon rock. So we need to take an EVA report from the moon's midlands. All right, we're going to store an experiment there. We're going to plant a flag. What do we call the flag? Yes, lights use power. Oh, everything's fallen over. That's unfortunate. The flag fell over. Okay, well, we'll try again. Plant the flag again, and this time please don't fall over. What do we put on the flag? We crashed here. I think this is the Midlands. Alright, so now we need to go find the Highlands. And I think this is Highlands right here. Which means we need to go west. And west is that way. So we're just going to turn on that jetpack and go fly off this way. And we'll use like half of our propellant this way and the other half to get back. Ian, do you think you could get a full flow stage combustion cycle working by next year for the 8th grade science fair? The honest answer to that is no. I don't think I could get a full flow stage combustion engine working by next year if you gave me $100,000. If you can, I can guarantee you will have a job at SpaceX. Like, hands down. Hernandez, the answer to your question is if you can build an Alcubierre drive, I can have it ready for you whichever science fair you want, all the way back to one Sir Isaac Newton was at. Oh, uh-oh. That was bad for Jeb. I think we killed him. Let's go unkill Jeb. Oh, this feels like cheating. I meant to quick save after I landed. Oh well, I guess I can't unload a quick save now. Alright, let's try landing again, and this time with less crashing. So we're going to try and land on the daylight side this time. This is what I get for paying attention to the chat instead of to where I'm flying. Yeah, Lars, sorry about the Kerbal. It's probably an OSHA finding. Ambient lighting is probably not a bad idea just so that everyone else can see what's going on as well. Is that one of the settings here? Ambient lighting. How do you do ambient lighting? Ambient lighting boost. All right, we'll do 50%. Okay. Is that better? Okay, that makes it a little easier to see. Vinfaz, I don't think Planet Shine works in this build of KSP, unfortunately. I could be wrong. All right, so now we're going to take this sample. Crew report. All right, good. So that contract is done. Contract complete. So now all we have to do is find a moon rock. So we're going to slam on the brakes. Crew report. This just says in space near the Mun. Does this have a biome? In space near the Mun. Alright, I need something that has a biome associated with it. That, unfortunately, none of those have biomes associated with them. So we're going to get Jeb out and see if he can tell us what biome we're in. Moon Highlands. Alright, so we're in the right place. That's good. So this is where we want to land. Alright. So now all I have to do is touch down on that very rocky terrain below us and find a moon rock. Oh wow, the comments are coming up with all kinds of hard and bad ideas. I don't know. I think the hard part here is we're in career mode, so we have to pay for our rockets. That isn't that difficulty enough? Or are you gonna make it even harder? Nope, we want to go this way. Alright, so we're just going to try and land right here. That looks like a moon rock right there, which is very convenient. So we want to kill all of this velocity. There we go. All right, so now we're falling straight down. So now all we have to do is not crash. And it's going to be real tight to get home, folks. Oh boy. You know, we're just going to stop doing this one of these days. It turns out landing vertically is hard. But we can still get Jeb out, and I think we can still take off like this. So we will, I guess, take our licks. And why is electric charge going down? Electric charge should not be going down. Is the solar panel not generating electricity? The solar panel is not generating electricity. Oh, because that's how high we've got the brightness turned up. Holy cow. All right, well, I guess I can't even tell that we landed on the dark side of the moon. Yeah. Wow, okay, so technically there's no light here. All right, well, we'll do this one more time. Surface sample, plant flag. And we're just going to call this Take 2 landing. And it may just be me, but it looks like that rocket is sliding down this, which is not awesome. We're going to log magnetometer data, take that data. Yeah. It would be a lot easier to not crash this if the legs were wider or the capsule wasn't as tall or I was just a less awful pilot or we landed literally somewhere, anywhere flat. But that's what we've got. So I guess the question now is, can we take off like this? But first we have to find a rock. And I swear, I think this is one here. Let's go hop over to the rock. Let's try not to kill Jeb this time. No crashing, no crashing. Oof. All right, that was uncomfortable. Sorry, Jeb. All right, so now we need to go find, let's see, what does this contract say? Bring back a Munstone on the Mun back to Kerbal orbit. Well, this is a stone on the Mun. How do you take a surface sample? EVA report. Does anyone know how to like pick this thing up? I can climb on top of it, but that doesn't feel like a how do you bring back a Munstone on the Mun back to Kerbal? Does anybody know how to do this? Pick up Munstone. There we go. All right, that's what I needed. Wow, that turned out to be surprisingly challenging. Okay. Munstone analysis. Wow, 120 science. That is a great deal. Oh, all right. Well, there goes the rock. Okay. So now we've got that. Now all we have to do is get home. No, Francis. What kind of attitude is that? You gotta bring back the biggest rock you can find. And obviously, we have no delta V issues whatsoever on this flight that might require me to eventually get out and push. All right, let's not crash. Don't crash. Don't crash. Don't crash. No crashing. Don't crash. There we go. We will do that. And let's check and make sure we still have that Munstone experiment. Munstone analysis, which we do. All right, awesome. So now all we have to do is take this data. And we can transmit this for 100% science. Let's do that. Oh, okay. Well, we don't have enough electric charge, so that's good. Okay. Let's turn the antenna off. And let's retract this so we don't break it off. Toggle magnetometer. There we go. Okay, so now we have to figure out how to take off like this. And I think the thing to do is going to be to retract the landing gear. And then... roll... There we go. And then when we face the right direction, we are going to light the engine. Oh boy. Ah! Okay, that was exciting. Let's go to space. Oh, we may need to launch another rescue mission on this one, guys. Yeah, that's gonna be a yes. All right, rescue mission! It's okay. We left the lunar surface, so now the rescue mission is a lot easier. Is anyone getting deja vu yet? Because I'm getting deja vu. How much delta V do I need to circularize? Alright, we aren't going to have to EVA to orbit. Probably. We may have to EVA to orbit a little bit. Oh boy. Alright. I feel like I just had to do this. Like, this is the second time. You know what, after this? After this, we're going to go on a nice, simple, easy, no possibility of making a mistake orbit where all we have to do is launch a comm satellite into the right orbit. Nothing could possibly go wrong from that. Oh, I'm also totally falling towards the ground and about to crash. Yeah, so the problem here is we still may not actually, like, quite make it into orbit. Which I don't think we have. Oh, excellent. All right, so we're not in orbit. So this means that it is once again going to be an EVA rescue. But before we go, we're going to grab the data from this. Take data. All right, now we have to go there, and quickly, before we hit the ground. Yes, someone summon Matt Lown because we need the Blunderbirds. But I think that should be us in orbit. Which is good. We are now in orbit, which is exciting and happy. So now we aren't going to hit the ground and crash and die. Which is good. This is good. Not crashing and dying is good. Let's see, how much Delta V? We have, I think, enough Delta V on the Kerbal that we can do a return from lunar orbit. You know what? We're not going to do that. We're gonna go build a rescue mission. That's what we're gonna do. Okay. All right. So we've yeeted him into orbit. Now we need to yeet him home, as Lars Osborne would say. And yes, Colin, consider this: we were flying like Iron Man. Definitely the way to do it. Okay. So the last time I flew this rescue mission, I did it without any control wheels, and while I'm sure that was entertaining for you guys, it was really just kind of stressful for me. So we are going to invent a rescue mission that doesn't involve me being an ace pilot. I say that like I just demonstrated anything other than ace piloting. So here's some control wheels, so we'll put those on. And now we'll add some electrical power. Okay, I think that fixes all of the problems. Plenty of Delta V, plenty of Delta V. All right, yeah. Rescue 2. And you know, I'm sure Valentina is getting tired of this, but we call upon her once again to rescue Jeb's sorry butt. Yeah, Francis, deja vu is exactly the words. Hi, Spring, welcome to the stream. Gabe, thank you for the subscription. Welcome to the channel. Mostly what I do does not involve playing Kerbal Space Program. Most of it involves building rocket engines. But sometimes I play Kerbal Space Program. And sometimes I even play Kerbal Space Program well enough to not need to launch rescue missions every other mission. Alright, so just start the gravity turn. We're here at 90 degrees through 1,000 meters. This maneuver in real life is called the pitch kick, and they literally do it just so that if the rocket blows up 10 seconds into flight, it doesn't kill the launch pad in the GSE, which I think is kind of funny. Someone should tell Amos 6 about pitch kicks. Getting a little bit of noodle factor here, but I think we'll survive. And that's booster burnout and jettison. And so we'll just kind of pitch all the way over to 45 degrees. So we're actually, I think, at a TWR below 1. Yeah, so our TWR just hit 1 again. So we're kind of not really as high thrust as I'd like, but we'll be fine. Alright, well I tell you what, we've got 20 people here, so what I will do as soon as we reach orbit is I will play a clip from an upcoming video I'm going to show when I'm allowed to about another rocket engine I've been working on, and I think it's kind of cool. It's not a very long one, it's only like 30 seconds long, but I think it looks cool. I'm a little concerned that we may not have the thrust-to-weight ratio we need on this mission. I feel kind of like we're falling about as much as we're going up. Dion, I probably actually can't talk about what happened on Amos 6, to be honest about it. Let's see, we've got 1,500 meters a second of delta V left in this. What's our apogee going to be? Our apoapsis is only 30 kilometers, which is really not enough. Dion, I have a pitch roll coupling problem not in Kerbal Space Program. I think I've lost 2 rockets to coning. I really think I have. Because the fins, like, it ripped through 14 plies of carbon fiber. Like, man, I tell you what, if coning killed Stratos 3. I really think Koning killed both Hermes 2 and Hermes 3. For those of you who don't know, I was on the MIT rocket team for several years, and I lost 2 rockets to a magical invisible barrier in the sky at about 8 kilometers up. Sorry, 8,000 feet up. And the rockets were going just fine, and then at 8,000 feet, the fins fell off exactly at Mach 3, and that was that. Alright. So, we've got 500 meters a second left to go before we reach orbit, so we'll ditch this stage so it re-enters and doesn't leave any space debris and circularize with this upper stage. And then we will plot our transfer to the moon to go rescue Jeb. How's Valentina doing? She has all this extra space since Jeb isn't in here causing problems. Mess with the radio settings. Alright, so that should be us in orbit, except it's not because I forgot to check where we were in our orbit, so we'll circularize out there in 6 minutes. Dion, what's you guys' TWR? I think you guys leave the rail at a higher TWR than we do, because we lift off at around TWR of 8, and we burn out at around a TWR of like 24. So thrust to weight ratio, or TWR, is how many times faster than the acceleration due to gravity the rocket can accelerate. And it's important to think about because if you are accelerating only at 1g, you actually won't ever go up. You'll only ever just be exactly canceling out the force of gravity. So for passively stabilized rockets, you not only need to accelerate upwards fast enough that you go towards space, but also you have to accelerate fast enough that your fins start working quickly enough that you don't flip out of control. All right. You're almost up at apogee. Just 1 more minute. There we go. Shiny. We're in orbit. So now I will keep my promise and show a video that I have coming up. So, enjoy. All right. So that was a little thing I whipped together. I will probably do the rest of that video. I don't know when it will release. That depends on both other people and other things, but that project is coming along super well, and I'm really excited for it. Um, don't know if you can guess too much from what I showed, but I think that's actually 100% of the parts um, on the engine. Uh-oh, are we having audio problems? No, it looks like the audio's okay. Audio check for it. Yeah, I think everything's working fine. So now I have to just plot this transfer from here to the mun. Oh, we've had a great question. What does the line in my logo symbolize? I'm curious, can anyone else guess what the line in the logo symbolizes? I think it seems pretty obvious to me, but I also made the logo, so maybe I'm the wrong person to ask. There we go. That's 500,000 feet. That's 350,000 feet. 94,000 feet. There we go. That's exactly what we want. Okay. The redstone hive is exactly right. It is the contour of a bell nozzle. All right. So now we need to get the spacecraft pointed at this maneuver node, which is coming up in 20 minutes. There we go. Spring, rocket engines are not something that you see in your everyday life, so I wouldn't expect anyone to know what it is. It's kind of a Easter egg for people who spend their whole life breathing, eating, sleeping, and living rocket engines. All right, we are 8 minutes away from this maneuver node to burn out towards the mun. 5 minutes, 3 minutes, 1 minute out from the burn. We should be able to do the entire burn with this stage, which will be convenient. Oh, crap. There we go. Oh, that's cool. You can see the mun eclipsing the sun just as the sun rises over Kerbin. That's absolutely beautiful. All right, coming up on engine shutdown and burnout. That's not a bad job. We got it within 4 meters a second. And our periapsis is down at 96 kilometers, which is exactly what we want. So we will just real quick save. Admire the absolutely stunning beauty of this game again. And we will head out towards the mun. Slam on the brakes. So now what we have to do is we have to burn retrograde to capture around the mun, and then do an inclination change to rendezvous with Jeb, and then not run out of gas. I say that right as the stage runs out of gas. So now we will drop this stage and light the second stage. Third stage, actually. This is our third stage. There we go. Okay. So let's see. So Jeb is flying. I think Jeb is going... Which way is Jeb going around the mun? He's going up. So when we get to here... This is good. This is less delta V than it could be. We could have done worse. So we need to add an inclination change maneuver right there that burns like that. And here's a pro tip, is that it is always more efficient to do your inclination changes at the same time you're doing height adjust burns. Um, if you just do an inclination burn and then you just do a height adjust burn, it will be less efficient than if you do them at the same time. That's not quite right, but we'll refine it a little bit once we get there. That's going to be a 400 meter a second burn, and we have 1,700 meters a second. Dion, it's cool. 8 Gs and 14 Gs of burnout. So it's weird that you were higher than us. I guess we weren't at burnout when our fin fell off. Oh, and you have an engine burn time of almost 40 seconds. Okay, that'll do it. Our burn time is 8 seconds. It's a real, we call it a real good kick in the pants. We really slam the accelerator when our rocket launches. Okay, so we are 6 seconds away from lighting this engine one more time. And there we go. Shut down. Okay. So there's us rendezvousing with Jeb. We are 3 degrees off inclination, so we will warp ahead a little bit and fix that, and then we will do our phasing. Dion, I haven't seen anybody do Mach 5. The only team I've seen even claim Mach 5, I think was maybe Princeton claimed Mach 5, and I'm not sure I believe it. Coleman's brilliant, but I'm not sure I buy it. Their composites work on their second stage was good, but I'm not sure it was that good. Okay, so it's 3 degrees, so we need to burn, I think this is also going to be north, so we need to point at this node. I'm flying kind of by guess and by golly here, which is not the right way to do this. Yeah, this is the right way. Okay. 2, 1... Okay. So that should be, like, really close. That node is, like, 1/10 of a degree. So now we need to get down to where Jeb is and figure out the phasing. It's kind of a back burner project right now, but I have a O3400 motor I'm gonna burn, and I'm gonna try and do Mach 3 sometime this summer, maybe at Balls. Balls is a big rocket launch that happens every September, but I'm looking to try and hit my own elusive high Mach number. Okay, so let's see. So Jeb is in front of us. So if we raise our orbit just a little bit, there we go. So for 8 meters a second, we can have a rendezvous in 2 orbits. So we're going to do that. So we'll set up for this maneuver in 1 minute and 30 seconds. Cosmic, there are a lot of people attempting orbit, and it means nothing. Really, the only team that I would believe right now if they said they were attempting orbit is USC, because USC's tried space and done space. Every other team has not done space. So for larger solid rocket motors, you would want to gimbal just the nozzle. I've looked at some designs for doing that like NASA uses for its SRBs, but it's just not worth it. Adding either a fin control mechanism or an RCS mechanism is just a lot easier than trying to gimbal the solid rocket exhaust, and the failure modes are a lot less bad. Like if the RCS system doesn't work late enough in flight, everything is fine. But if your like flexible nozzle seal doesn't work, the whole motor's destroyed. Oh, that was bad. I overburned, so I'll have to go back and fix that. I forgot that was a really gentle burn. There we go. Okay, so now we're only going to be a half kilometer apart. So we will do a target retrograde burn in half an orbit. Colin, to my knowledge, Purdue is doing Methalox. I think it's called Boomy Zoomy. Hernandez, yes, I did go to MIT. Yeah, Dion, it's so true. Being able to launch from a high altitude is so great for your apogee. Um, and that's even if you really know you're going to do it, you can optimize your nozzle geometry for the higher initial altitude. Colin, the L1 cert lets you strap together motors up to I believe 1,000 640 newton seconds of impulse. So that is a maximum of 2 motors. All right, so we're 40 meters a second off on our target delta V. 4, 3, 2, 1. There we go. So now we will switch over to Jeb and have Jeb. Jeb is actually a little too far away. So we're going to fly over towards Jeb here real quick, and then we'll have him do the rest of the rendezvous. 2.5. Let's see, 1.4. So Hernandez, getting into MIT is challenging, and I don't know how. I mean, the acceptance rate has just gotten so low these days just because so many people apply that there's just not like one way to do it. If you try and get into MIT the same way that someone else did, then you won't get in because they already have one of whatever that person is. So you really kind of have to find your own way. And it's not very satisfying to say that, but like the obvious answer is like get good test scores and then have a compelling application. Ian, I think that the launches will be intended to continue. It is unclear if the companies have the supply chain and the personnel to continue with the launches, but I think the government will want them to continue. Oh, wow, that just looks beautiful. That is spectacular. Okay, so where is the spacecraft? It should be like right around here somewhere. Somewhere? Set as target. There it is. Right there. Oh. There we go. Now we're thrusting in the right direction. $80 meters away. The Redstone Hive, there is a safe way to do sugar motors. I just don't know why you would like want to involve yourself in it because composite motors are higher performance and just about the same price. So if you're going to do sugar motors the safe way and composite motors are already safer and higher performance, it kind of just makes sense just to do the composite motors. Um, like it's just easy. Um, I mean, it's of course up to you. If you want to do sugar motors because some other reason, I mean, that's certainly fine. I know people out at the far site that do sugar motors, um, and they do sugar motors because they're cheaper on a per pound of propellant cost basis. So for really big motors, you can save some money that way. Hi, can I please get into the capsule? It'd be great if you could let me in. Thank you. Valentina, open the door, please. Uh-oh. There is a door on this capsule, I know, because we just did this last time. Is that it? There it is. Never mind. Okay. Here we go. So yeah, so the safe way to do sugar is to not do PVC pipe cases. You have to have a mentor who knows how to cook the propellant in a very safe way. You have to have a electric double boiler. Like you just have to have a lot of equipment. So there's like hardly any point to like do it that way when you could just make a composite motor for practically the same amount of money, but it'd be, much higher performance. Okay, so now that we've got this, now we just need to get home. So I think we will add a maneuver here. No, that is going to be us ejecting us from the moon. So we need to add it 180 degrees out of phase from that. There we go. That's what we want right there. So we'll just go ahead and fly this trajectory, and that'll take care of us. Yeah, Dion, I think Corral is a little bit different. How you say that? The French Guiana launch site, because it's multinational and it's on another continent, so you have to travel to get to there. Whereas, for example, in the United States, all the workers that would launch a rocket from Cape Canaveral are already at Cape Canaveral. Um, Redstone Hive, you do have to have access to an L2 cert to do motors with Tripoli, but you don't have to have an L2 cert just to like buy AP. Um, if I were you, though, I would try and find a nearby Tripoli Rocketry Association member who makes their own motors, and then he will probably be excited to show you how to use his chemicals and his equipment. And then you get free chemicals and experience, and you don't have to have an L2. Cosmic, you don't need a license for composite propellants from the government. To fly them at a Tripoli launch, you do that. Uh, let's see. The thing you have to remember is that the U.S. has this weird conglomerations of regulations from the government and from insurance and from the launch sites you might use. So you have to figure out like why is this regulated and who is regulating it. So for example, the L2 is required by Tripoli, not by the government. See you, Hernandez. Okay, let's see. We are 23 minutes away from this maneuver. Oh, well, Redstone Hive, I can't speak to the regulations in New Zealand. You need to find someone from New Zealand who can uh, talk to you about the regulations in New Zealand. It is important that you understand your local regulations, both so you don't get in trouble and so that you don't possibly get other people into trouble with your rocketry experiments. I'm like a little concerned at how low we got there. I probably should have checked. I feel like there could have been like a sudden terrain contacting event if we'd been a little less lucky during that whole little nice little drop down low. All right, we are almost at our trip home, and then we can finally sign off on this lunar mission success. You know, Dion, I'm actually really quite disappointed that this whole virus thing happened for obvious reasons, but also because I'd hoped to go to Europe this summer. I'd received an invitation to tour a couple of launch companies on your side of the pond, as the British would say, and I was really excited for it. But it looks like that's probably going to have to wait until some other opportunity. But when I do, I'll have to see if I can come see the neck of the woods you hang out in. Let's see. 30 seconds. 20 seconds. Coming up on main engine start. 5, 4, 3, 2, 1, and ignition. All right, let's go ahead and get out of here. 90 meters a second left, 60, 50, 40, 30, 20. Shut down. We went a little too. We were a little excessive. But that worked out fine because we have a 90,000 kilometer apoapsis perigee. Well, you know, Dion, if you ever come to the U.S. and you need a place to crash in Colorado, I would be happy to extend you some hospitality and buy you a beer. You'd owe me some rocket stories, though. Let's see. So what we're going to do now is we are going to pull in our periapsis just a little bit, down to like 50 kilometers, 45, 30, 39. All right, there we go. And now we're going to use the last of our propellant to slam on the brakes. I'm sorry to hear that, Kenji. That's no fun to have the plans suddenly rescheduled by things out of your control. Alright, so we're going to slow down now so that our entry is not nearly so harsh. Dion, I know this phenomenon well. Yeah, Redstone, PVC piping is just not a casing material you should use under any circumstances. It's just not great. Okay, so we got down to 2,300 meters a second, so this should be a nice chill entry. It's going to be a little steep, which is maybe not great. I probably should have attempted to modulate my descent, but I think I've got enough heat shield on it that we can survive even a really steep entry. Yeah. Oh boy. Here we go. We're at 2 Gs. We are at 5 Gs. Oh, that wasn't so bad. Only 5 Gs on entry. That's just like a normal ballistic entry. Alright, that was... Thankfully we survived that relatively steep entry. So let's go ahead and get a parachute out before we litho break this capsule. There we go, and the parachute pops open. You know, at the risk of encouraging it, I tested over 120 PVC pipe case rocket motors made with sugar propellant in my very early days in rocketry. And the discovery that I made is that they're an awful idea, and you will spend more money trying to make them work than if you just bought one aluminum case that was done right. Alright, let's grab a real quick crew report. and recover this mission, and call that a launch. All right, so whew. I feel that, Dion. That is a true story right there. That's a I made my first PVC pipe motors with water putty nozzles with the 3D printed mold. Okay, so we got 750 science. And we got like another $250,000 from the Kerbal funding agency. Oh wow, this is like cheatingly easy. Yes, please, I will take this contract. Okay, so now what we need to do is we need to build a satellite that can fly to these two orbits. This orbit and this orbit. Let's see, so they share a node there, so it should be possible to hit both of these with a single launch. Yeah, Dion, I never added any iron oxide to my propellant, and I'm relatively happy with myself for that choice. Vinfaz, if you're thinking about 3D printed cases, I've actually 3D printed a rocket motor out of plastic before, the case out of plastic, and the nozzle. It was kind of an awful idea, but it was a drunken bet, and Tori Bruno came by our lab and test fired one of the motors for us. So of course, we had 7 tests, we had 6 successful tests, and on the very last one was of course the one that Tori Bruno was there for, and it was the one that exploded. So Nylon X is actually a relatively good choice for 3D printing a rocket motor case out of because it leaves behind an ablative char layer as the nylon boils off. Colin, to be honest, the reason you were shut down hard on the Rocketry forum is because most people who show up there and say they want to build rocket motors don't have enough experience to do it safely, and they don't have a mentor to help them figure out how to do it safely. So it's a risk for them to say anything other than don't do it because if you got hurt, it would reflect poorly on them. So the honest answer, Colin, is you probably shouldn't. Unless you're really sure you know what you're doing. And when I say you're really sure what you know what you're doing, like I spent several months reading how rocket motors were built and how they worked before I built my first motor. And when I did build my first motor, it was with the benefit of all of the work that Richard Naka had done and all the reading that I had done. So it was a somewhat safer adventure. Vinfaz, actually, if you give me 1 second, I will link you to the technical report that my friends and I did. Let's see, where is it? Here it is. Yeah. There you go. That is the time I 3D printed a plastic rocket motor. All right, let's just see how quick we can do this. So I like this rocket, but I don't think we need all of this rocket. So what we're going to do is we're going to ditch that, put that there, pull that off, pull that off, get rid of you. What is the difference between these? This has a tiny antenna and 10 electric charge. This has a fancier control module and reaction wheels. Okay, so we want this one. Let's see, so we got that. What do we need else on this? We need a battery. We need some solar panels. 1, 2, 3, 4, 5, 6, 7, 8. We need to look at the contracts. I think the contract has requirements. Build a new unmanned probe that has an antenna and can generate power. Reach the designated polar orbit and maintain stability for 10 seconds. Build a new uncrewed probe that has an antenna and can generate power. Reach the designated orbit, have a materials bay, a thermometer, and maintain stability for 10 seconds. So we need that. So we need the materials. A materials bay. I think this is the materials bay. Yeah, materials bay. And a thermometer. But not that many thermometers. Just one. And an antenna. And an antenna. We'll do like 3 antennas. There we go. Okay, so this is a spacecraft, and we'll throw a reaction wheel on it just to be safe. Okay. And you know what we're going to do? Actually, also, we're going to put these here and here, and we'll put them on the back, and then we're going to put RCS tanks down there. You go there, and we'll put one of you there. This looks kind of like a spacecraft, right? There we go. Okay, this is what the spacecraft's going to look like. So I need some RCS tanks. Oh, we haven't invented RCS yet. So let's just do this real quick. So we can save it as Kerbal 1. Kerbal Stationary Sat 1. Save. Let's go do some research. The redstone hive, the exhaust is shooting off in random directions because of asymmetric erosion of the plastic as it burned. Also, we didn't get the pressure really quite as high as we wanted. We would have preferred it to be somewhat higher, but the throat was already eroded out some. Yes, Dion, there was this guy from a group called Stofiel Aerospace that claimed that he'd done this for like years and years, and he has some weird fake aerospike nozzle technology. And it's really funny because if you watch his videos, you can see he's not even getting supersonic flow in his exhaust. He got very mad at us. He called us fake news. He said that we were just trying to bully him out of his rightful accomplishment. Quite frankly, I think he had not accomplished his accomplishment, but whatever. If he succeeds, power to him. We always want more Rocketeers in the world. Oh, wow. Okay, so we have, like, tons of science left. So what do we want to start getting science for? So I just bought RCS systems. And this has space telescope parts and rover parts. That could be kind of fun. I guess we're going to want to start doing airplane things, so we'll buy airplane parts just because they're cheap. This has tiny engines. This is another good thing to get. This has big rocket engines and big fuel tanks. No, this does not have big fuel tanks. This has tiny fuel tanks. This has big fuel tanks. All right, so we want that. Excuse me. Right you are, Dion. Right you are. So everyone who doesn't know, Arca is this company that's working on this like rocket technology, and they'll tell anyone who will listen about how they're the only environmentally conscious rocket technology because they use water as their propellant, which is funny because they're not even like using like a hydrogen oxygen rocket, which they like apparently also think is bad for the environment. They're just like straight up using like actual water that they heat up like a 8th grade science experiment. Oh boy. Okay, so command modules. We're gonna grab bigger command modules, and we have 200 science left. What do we do with our 200 science? We could get more airplane parts. Ooh, advanced construction. I think this has docking ports. Oh, this has robotic arms. Okay, no, we want this. This is exactly what we want. Okay, we're getting this. Cool. And we've managed to spend like hundreds of science just like that. Yeah, steam rocket. What an awful idea. Okay, so we've done that. And now we need to finish building our rocket. Colin, it's not interesting. It's just sad. I feel bad for whatever like venture capitalist is going to take them seriously and get his money taken away. Okay. Fuel tanks. We'll do like... There we go. And now let's put an engine underneath of it. This one burn monoprop? No, this is a biprop engine. Huh. I don't have any monoprop engine yet. I guess we have to use RCS thrusters. Let's see. We'll just do 4. There we go. And then we'll need a decoupler, just a tiny one. Oh. I apparently do not yet have the tiniest decouplers, so we'll use this big one there. Oh, and then we need a fairing. Let's see, fairing. 1.25 meter fairing. Just come out a little bit to get around these RCS tanks. There we go. Rocket. 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 More rocket. All right, beautiful. 23,000 Kerbucks, and we're going to get how much from the contract? Let's make sure we're actually making money on this before I go ahead and decide it's a good idea. So we will save this, and we will check the redstone hive. It isn't bad for the... I mean, it is kind of bad for the environment because of all the water vapor in the high upper atmosphere, but it's not that bad for the environment. It really isn't. It just kind of betrays the fact that they really have no idea what they're doing. And it's funny because they get really offended when you tell them they're doing something dumb. They like make like response videos and clap back on the internet when like Scott Manley calls them out, and it's really hilarious. It'd be like if SpaceX like got mad at every person who said reusability was impossible in like 2009. Okay, so we're checking what the payout for this contract is. 89,000 space bucks. And this one is 136,000 space bucks. So we'll make like 200,000 space bucks, which I think is a great deal. Okay. Ian, Arca is supposedly still working on their aerospike. I don't know how it's helpful since they're burning out at 10,000 feet, so they don't even keep their aerospike long enough to be useful. What other hobbies would I take up if I could no longer do rocketry? Well, I play piano. I play violin very poorly. Um, I enjoy hiking and climbing. I enjoy scuba diving when the weather is not freezing cold outside. I enjoy machining non-rocketry things. I have several 3D printers that I tinker with. I do a lot. I probably need fewer hobbies, not more hobbies. All right, I think this is ready to fly, so let's go launch it. Colin, if you just tell the public that hydrogen and oxygen releases the chemical called dihydrogen monoxide, which has a 100% mortality rate for people who ingest dihydrogen monoxide, I think you could get the public to very quickly react against hydrogen propellant rockets. Um, Check yo staging. I feel like staging needs to be checked. You are correct. That works. That works. That could use its own stage. All right, cool. Thank you for the tip. Always check your staging. All right, so we'll just do a little quick pitch program. Where's the sun? Apparently it's directly overhead and I was incapable of finding it. Yep, it's right there. Alright, we are coming up on SRB burnout and jet here in like 2 seconds. 2, 1, burnout and jettison. Bye-bye. And we'll keep pitching over. Oh wow, we have way too much delta V on this rocket. I should have like calmed down like a lot. We can SSTO this stage. We can probably use this stage to put us into this orbit here, and then use the second stage just for getting to this orbit over here. We've got 2 minutes of burn left on this stage. TWR of 1.5 and 2.8 kilometers a second of delta V, which will be plenty to make orbit. Just checking real fast, we have an apoapsis of 37 kilometers. Dion, this mission, we don't get paid to go to Duna, we get paid to launch this ComSat. You know, the Redstone Hive, when I started playing Kerbal Space Program, they only had these 1.25 meter parts. They didn't even have like the 2.5 meter parts. So when they added those, it was like a huge deal that like they had these like giant sized rocket parts. Getting to the moon involved like lots and lots and lots of those like 1.25 meter tanks. So they didn't even have the double long tanks. They literally only had this tank in the game, 3 rocket engines, and 1 command pod. It was ridiculous. All right, that is almost out of the atmosphere. I think that's about good. 107 kilometers. We'll just soar on up there. All right, 70 kilometers. We can do real-time warp now. Let's get rid of this fairing since it's just dead weight at the moment. Bye-bye, fairing. Thank you for your service. There we go. And we'll just keep an eye on our periapsis. There we go. Actually, we're just going to keep going because we need to be all the way up out here. Oh no, we don't want to do that. We want to go here so that we have the most efficient inclination change. I really should have just launched into the correct inclination, to be honest. That was kind of stupid. I really should have done a better job of that, but I just didn't think it through. So that'll set us up there. So we just need to time warp around to that maneuver. All right. We want to start the burn in 18 seconds. And go at throttle up. You know, the Redstone Hive, they did have SRBs. They were just not particularly useful. I'd kind of forgotten about that. They looked really ugly. Man, those were just the ugliest parts. 12, 10, 9, 8. There we go. Okay. So now what we have to do... so when we get out here, we have to circularize and inclination change. That looks like about exactly what needs to happen. So we will just fly that maneuver when we get there. I think there's a feature thing now where you can, like, time warp to maneuver. I swear there's a way to do that. I guess that's not a thing you can do? Okay, whatever. Alright, let me get out here. We're like 5 minutes away from that. Oh, but we've got to, like, reorient hard. Get pointed the right direction. Thankfully, we seem to have plenty of antenna on this. All right, there we go. 2 minutes. 1 minute. 10 seconds. Coming up on main engine relight. Here in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. Okay. We're gonna have enough delta V for this? We are going to have enough delta V for this in this stage, I think. No, we have to stage once. Yep, so we will stage and then light this stage. Okay. So that got us kind of more or less into the right orbit. We still got to fix it a little bit. So we're going to set about doing that by coming over here to periapsis and raising our apoapsis. And a little easier on the delta V. There we go. All right, so now we need to make this maneuver happen. Which should be relatively straightforward in 2 hours or something. Yeah, that was actually an SSTO. That was like a single stage to geostationary orbit. It probably could have single staged to orbit without the SRBs, to be honest. I didn't really plan ahead that well. I should have checked the Delta V. I could have gotten away with a much smaller launcher. This is going to be a really short burn. But we'll do it at low thrust because I really want to nail these parameters home. Let's see. There we go. Okay. Reach the designated orbit. Oh, we're already in the orbit. I don't even have to do more synchronization. I just have to wait for 10 seconds. Bingo! There we go. We got the contract. That was actually easier than I expected. So now we have to reach this new orbit. We've got 2,000 meters a second of delta V to do that with. So we need to add a maneuver right there. And we need to go like this. Oh man, this is like a 90-degree inclination change. Funny story, if you do out the math, it turns out it's easier if you have to do more than a 60-degree inclination change. It is less delta V to land your payload and relaunch it. True story. Okay. It's freaking weird. So the problem with maneuver nodes and inclination changes is that it doesn't actually sweep the orbit with the node as it changes, since your nodes move if you're doing a normal or anti-normal burn. So messing with the maneuver nodes is really weird because eventually you get to a point where your control directions are no longer orthogonal. Which is what was happening there. But luckily, I think I've got a maneuver calculated that's going to get us into the right orbit. So all we got to do is nail this burn here in 6 minutes. Oh boy. We're still going to do it. We'll figure it out later. We'll fix it in post. Okay, there we go. That was not exactly what I wanted to do, but it was a thing. Now we're only 3 degrees off on the inclination, so we need to burn east, I think, here at this node here. Is that an F? I don't think I messed up F bad. I guess it's just like a little timing adjustment. We had enough delta V margin built in so that we could afford to delay the count a little bit, and everything will be fine. And it's just going to be like a few meters a second to fix it right here. Yeah, like 30 meters a second and this problem all goes away. The alternative was like we could have waited like several days to like try a different trajectory. So look at how much easier this is. It's just going to be 45 meters a second and our problem goes away. In 2 minutes. We're actually not going to miss the burn this time because that would be bad. And I'm going to quick save in case I do miss the burn. I can reload it. 50, 20. All right, here we go. It was a small f. All right. I will accept a small f. And shut down. Okay, so now we need to come here and burn retrograde. There we go. That's exactly the maneuver window. Only 87 meters a second. This is going to be super cheap. This will be very easy. And then we will get this contract as well. Or is that what we're gonna do, Dion? Or are we gonna end of life this thing into the mud? No, I think this is a communication satellite, right? It's supposed to provide services for all Kerbals for years to come. You know, improve quality of life, get in the way of astronomers' telescopes. You know, like communication satellites are supposed to. Gabe, I do streams about every 2 weeks. Sometimes, mostly when I feel like it. When I'm streaming video games. Sometimes I'll stream me working on my rocket engine. And those happen when I have things that I can stream working on. Like, I'll probably do a stream here in a bit because I have a bunch of fittings I have to Teflon tape and fit together and torque. 20 seconds. 3, 2, 1, ignition. And shut down. And let's see if we did it. Stability for 10 seconds and all the parameters. Awesome. There we go. We did it. We got that contract. All right. That means that it is time to stage off the satellite and point it into its we don't want it like that. We'll point it like that. There we go. And we'll take a material science reading just because we can. I wonder if we'll get any science from it. We will, and we can transmit that science. Awesome. Okay. We even got some science from this mission. What a day. 18 science. How about it? Space Center. All right. I think we have one more mission we need to complete for today, and then we can kind of wrap the stream up. And this is going to be the most challenging mission of the day. We just accepted this contract, and we cannot end today without successfully fulfilling this contract. And this contract is we have to test the TD-25 decoupler landed on Kerbin. Not you. You. Yeah. Kerbin landed TD-25. All right, watch this. This is going to be the best test of any part that has ever been done in all of Kerbal Space Program. It will require the best of our energies, but we will do it not because it is easy, but because it is hard. And here comes this glorious test in 3, 2, 1. Ah, you see that? Contract awarded. Yeah. Contract awarded. Boom. We can recover this capsule. We will get 100% of value back from it. Oh man, what a great contract. I can't believe we got paid to do that. All right. So, we have 140 science. So we could get actuators, which has winches, grabbing units. Ooh, grabbing units could be fun. We could do asteroid next time. Yeah, we'll do that. Oh, we don't have 160. Okay, never mind, we won't. We will upgrade this, though, so we get unknown object tracking, so we start finding asteroids. That's going to be 85,000. We won't do that yet. We will do that. We'll spend some money. That needs like 1.7 million Kerbucks. We'll worry about that later. Unlimited active Kerbals. We don't need any more Kerbals yet. Administration building. What is this? The administration building. Oh man, wow. Okay, I actually don't care about any of these. And we don't really use the spaceplane hangar. But upgrading mission control seems like a useful thing to do. All right, so that about does it for here. So thank you for watching this stream. We have successfully done some things and successfully recovered from some things we didn't successfully do the first time. But I think that's going to wrap it up for today. So thank you all for watching, and stay tuned for future videos about liquid rocket engines and solid rocket engines, and a video about hybrid rocket engines, if you can even believe it. And engines that fit in none of those categories at all, but are still in fact rockets. Yeah, that will do it for me. This is Charlie Garcia, signing off.